And hi everyone. So we are from 2BCS11. So today we will present about communication principle for semester 1 2022 and 2023. So today's topic is pulse chord modulation, in short PCM. So we have Damia Batrisha bin Muhammad Afizul, Faisal Kamal Zuhaili bin Zukaria, Khalif Izzaddin bin Amran, Khan Elham Afros, and Muhammad Abdul Qayyum. So for introduction to PCM. Pulse chord modulation (PCM) is a digital scheme for transmitting analog data. It's convert an analog signal to digital form. Using PCM, it is possible to digitize all form of analog data, including full motion video, voice, music, telemetry, and etc. To obtain a PCM signal from an analog signal at the source, which is transmitter of a communication circuit, the analog signal is sampled at regular time interval. The sampling rate is several times the maximum frequency of the analog signal. The instantaneous amplitude of the analog signal at each sample is rounded off to the nearest of several specific, which is predetermined level quantization. The number of level is always a power of 2. The output of a pulse chord modulator is a series of binary numbers, each represented by some power of 2 bits. At the destination of the communication circuit, the pulse chord modulator converts the binary numbers back into pulses, having the same quantum levels as those in the modulator. These pulses are further processed to restore the original analog waveform. So that's all from me. Thank you.
Hi, my name is Damia Patricia Benjamin Fizul. So today I will do exercise number 1. What is the frequency of the analog signal that has been used in the example 1? So we can see example 1 over here. Actually, I already did the code earlier. So this is the code that I provided in the sheets. So let's run the code. So we can see this is figure 3 square signal, encoded signal and decoded signal, and analog signal, sample signal. So the question asks us the frequency of analog signal. We can see for the period we can get 1 cycle 100 seconds for the period. So we can substitute the 100 second into the formula, which is F equal to 1 over T, F equal to 1 over 100 equal to 0.01 Hertz. That's all from me. Thank you.
Assalamualaikum and hi everyone. I am Ilham Afroz Khan. I will explain example 2, which is about compounding and without compounding for the given pulse code modulation by using compressing and expanding. First, we declare time t equal to 0, 0.01 to 3. Next, we declare message signal x equal to sine 2 pi t, here frequency equal to 1. Next, we declare quantizing bits n equal to 3 as given. Here, c equal to variable compound function. Next, x equal to message signal 255 is the value of compressor and 1 is the maximum range of message signal. After that, we declare E equal to UN code, the signal after quantizing, D U decode, the signal after receiving, and we declare O equal to compound as expanding the signal after receiving. Here we plot the given code for figure 1, which is compounding, and figure 2 as without compounding. Now we run the code and get figure 1 as compounding signal and figure 2 as without compounding signal. Next, I will explain exercise 2. In exercise 2, basically we have to generate an analog signal of 2 kHz using quantizing bits of 8 and 16. First, we have to change the frequency to 1000 and we have to also decrease the increment of the time. Next, we have to change the value n equal to 8. Now we can run the code and see that figure 1 as compounding it and figure 2 is without compounding. This two figure is much better and much accurate from previous one. Next, I change the value to 16. And we can see the signal of figure 1 and figure 2 is more accurate. For exercise 2 calculation, first n equal to 8 and small n equal to 3. Then we calculate dr equal to 20 log 2 power of 3 and get 18.06 dB. Then Sn we get 19.82 dB, and for Sn whole cube we get 10 log 3 to the power 2 whole 2, and we get the result 22.83 dB. And for n equal to 16 and small n equal to 4, we get dr equal to 24.08 dB, Sn equal to 25.84 dB, and for Sn whole cube, we calculate 10 log 3 2 to the power 4 whole 2, and we get the value 28.85 dB. That's all for exercise 2. Thank you.
Okay, Assalamualaikum. My name is Muhammad Abdul Qayyum. My number metric is 00821103343. So today I'm gonna show the exercise 3, example 1 and example 2. So this is the recording. Yeah. Recording. So this is the simulating for the example 1. For the first one is for the signal generator. So this is for the scope 1. Okay. So for the signal generator, go to the dot product, and this is the bit, because they want 8 equal to 3 bit. So symbols this. So this is scope 3. So this scope 3 again. So this is the final scope. So for the power supply generator, this is the scope 2. So this is the output. For the example 2, also same, is from the sine wave, and this is the clock. Okay. We go to the divide too. Okay, so this is the bit. So okay, so this is the output. Oh sorry. This is for the output. Okay. So the next one is also same, but from the sine wave, go to divide 1, go to the compressor. This is the compressor. So this is peak, and this is the decoder. So bit 3 because they want 8. So same goes this decoder. So this is the scope 1. So this is the output. This is also the example. If you want the sine wave, go to divide straight to the output. So this. Okay, that's all. Thank you.
And very good evening. From the project, we have discussed that from the PCM pulse code modulation above, we can say that it can encode a message by converting them into binary bits. This can rather be called source code. Plus, we found out that PCM is resistant to noise and can process digitally. Furthermore, PCM can only be used in the digital domain and not in the analog domain. The AD converter is used to convert the continuous message signal into digital number. This means each number represents a level of the quantized message signal. As soon as the quantized signal is in the digital domain, it will be much easier to generate signal processing by only applying the required mathematical equation. Apart from that, a DA converter does the opposite of what a DA converter does. It simply changes digital number to analog voltage. So, in conclusion, as we learn pulse mode modulation (PCM), we discover its advantages and disadvantages. The advantages were convenient for long-distance communication, has a higher transmitter efficiency, and has a higher noise immunity. Then the disadvantages are it requires large bandwidth as compared to analog system. Secondly, its encoding, decoding, and quantizing circuit of PCM is very complex. PCM are widely used in the satellite transmission system. It is also used in space communication and telephony. To compare this, CD is a recent application of PCM. So that is all for group 2. Thank you.